1/137, a disciplined insult. It has been called a code, a prophecy, a secret, and the number of the universe. It is still just a number, and that does not make it harmless, because this number has a very specific problem. Physics can use it, measure it, and rely on it, but still cannot fully explain why it has this value and not another. That is why people kept coming back to it. Most people know it in its public form, 1/137. That shorthand is memorable. It is also misleading, because 137 is not the number. It is the simplified costume the number wears in public, and that costume has been distorting judgment for more than a century. In physics, the number itself is called the fine structure constant. Physicists usually write it as alpha. You do not need the full machinery of quantum physics here. What matters is simpler than that. Alpha behaves like one of those keys that opens many doors. It helps physics describe how light and electric charge interact. It shows up in atoms. It shows up in calculations that work. It behaves like something fundamental, and it does not explain itself. Act 1. The Stumble. Alpha entered physics not as a revelation, but as a fix. In 1916, Arnold Sommerfeld was trying to improve Niels Bohr's model of the atom. Bohr's model worked, up to a point, but hydrogen was already being difficult. The light it gave off was more complicated than the theory expected. Some lines in its spectrum were split into smaller structures, and the theory needed a way to account for that. Sommerfeld tried to provide one. He expanded Bohr's model, allowed more complicated electron orbits, and added relativistic corrections, and in that work, alpha appeared. At that stage, it was a useful term in the mathematics of atomic structure. It helped account for the fine splitting in hydrogen spectrum. That part matters because it keeps the story honest. Sommerfeld was not chasing a cosmic secret. He was trying to repair a model that was no longer clean enough for the evidence in front of him. He was working through a technical problem and found a number that turned out to be more durable than the theory that first carried it. At first, the number even had a relatively simple meaning. In Sommerfeld's picture, alpha could be understood as the ratio between the electron's speed in the first Bohr orbit and the speed of light. But the simplicity did not last. Later, quantum theory discarded most of the old orbit picture. The scaffolding changed. The atom was no longer imagined that way. The number stayed. And once a number survives the death of the model that first introduced it, it stops looking like a local solution. It starts looking like a demand. Act 2. The Humbling. Arthur Eddington looked at the inverse of the fine structure constant and decided that measurement was not enough. A number like this, in his view, should not simply be observed. It should be derived. Exactly. Not as a stubborn empirical value, but as something theory ought to be able to produce. The temptation is easy to understand. A number with no units, sitting in important equations, starts to look less like a detail and more like structure. To Eddington, it looked like the kind of thing theory should be able to own. So he tried to own it. At first, Eddington arrived at 136. Later, he moved to 137. The important part was not the change, it was the insistence behind it. A constant that had entered physics as part of a repair job was now being treated as something that should close into an exact integer. It did not. Measurements improved, the number remained, but it would not settle into the kind of exactness Eddington wanted from it. It could be used. It could be calculated with. It could be measured more and more precisely. What it would not do was become the neat, theoretical answer he had asked of it. And the more sharply physics measured it, the less room that exact integer had left to hide. That failure did not make the number smaller. It made it harder to ignore. Act 3. The Temptation. Wolfgang Pauli was not a crank. He was one of the major theoretical physicists of the 20th century. By the time the fine structure constant reached him, it had already survived the model that first carried it, and refused every attempt to make it exact. That left a different kind of problem behind. Not how to use the constant. Physics could already do that. The harder question was why a number like this should sit where it did, with this value, in this world. Pauli was not in the habit of leaving a problem alone. He did not leave this one alone either. With him, the number stopped being only a technical object. It also became an intellectual fixation. In 1932, during a severe personal crisis, Pauli sought help from Carl Gustav Jung. What followed was not a random collision between physics and psychology, but a long relationship that moved from therapy into correspondence, interpretation, and shared argument about order, pattern, and meaning. It also became part of the wider background from which Jung developed his idea of synchronicity, his term for meaningful coincidence. The fine structure constant was one of the places where those pressures met. This is not because Jung explained the number. He did not. It is because the number had become the kind of object that could no longer remain purely technical. It had become too exact, too central, too unresolved, the sort of thing that invites thought far beyond its original job. By the end, the history had acquired one detail too neat to be useful. In late 1958, Pauli was seriously ill in Zurich. He was placed in room 137. He noticed the number. He died there shortly afterward. It proves nothing. It explains nothing. It changes nothing in physics. But it is the kind of image that attaches itself to a story like this and refuses to leave. Act 4. The Precision. Modern physics answered the mythology the only way it could, with measurement. Repeated measurement. Sharper measurement. Measurement good enough to leave fantasy less and less room to stand. The current recommended value is close enough for the old shorthand to survive, but not close enough to make it true. So the number survives its own mythology again. Not because it turned out to be mystical, not because Eddington forced it shut, not because Pauli died in room 137. It survives because physics can measure it, use it, and test it to absurd precision. And after all that, it still cannot justify itself.